Hi, so if you want more examples of ionic bond formation through LEDs, then we'll tackle a few in this video, so just some additional one. So for example, you have calcium, Ca, and sulfur. Okay, so maybe a question will be, based on the electron dot symbols, what, what will be the resulting chemical formula for uh, the compound having calcium and sulfur. So if you've noticed, calcium belongs to group 2A, so therefore it must have 2 electrons, while sulfur belongs to group 6A, so it must have 6 valence electrons. So if we try to draw the LEDs of those elements, okay, so this is Ca, has 2 valence electrons, and then if you let it react with sulfur, which has 6 valence electrons, 1, 2, 3, 4, 5, and then 6. Take note that in order for the shell of sulfur to be complete, it also needs 2 valence electrons. So what we can do is transfer the 2 electrons of calcium to the sulfur atom, such that it will have 1 new atom, and this also will be transferred, okay, as another electron for sulfur. So that means the result will be Ca 2 plus, okay, do not forget the charge, and then we'll have to enclose it in a bracket, right? And then sulfur has 2 new electrons represented by X's here, okay, and there's only 1 ion for sulfur, so that's fine if we don't place a coefficient. Okay, if there were 2 atoms of sulfur, then we place 2 before the bracket. Okay, and then don't forget the charge. So that means we have the following formula. Okay, the smallest whole number ratio, which we also call our empirical formula, CaS. Okay, so that's calcium sulfide. That's supposed to be a big letter C. All right. Now, what if we have let's say aluminum and oxygen, Al and O. So what type or what compound can we get by letting aluminum react with oxygen? So if you've noticed, aluminum belongs to group 3A. So that means there are 3 valence electrons for aluminum, and then for oxygen it belongs to group 6A. So there are 6 electrons, valence electrons for oxygen. So we start with writing one more electron, or one atom for aluminum. So this is Al, having 3 valence electrons, 1, 2, 3. And then we also have oxygen, 1, 2, 3, 4, 5, and then 6. Okay, so take note that our oxygen here lacks 2 more electrons to be complete, right? So what we can do is transfer 2 electrons of aluminum into the oxygen atom. Okay, so it's quite messy, but the arrows my dogs seem to like taking over the discussion. Okay, next, this electron also from aluminum will be transferred to fill up the space here. Okay, so if you've noticed, there are now 8 valence electrons for oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Alright, but sir, what happens to this 1 valence electrons? Take note that if there is an unpaired electron, this becomes a radical, a free radical. So that means it's very reactive. So what happens? Okay, we add another oxygen atom, okay, that lacks electrons. So 1, 2, 3, 4, 5, 6. Okay, oxygen has 6 valence electrons, and we transfer this one electron from aluminum there. Okay, and so you have this structure. Okay, but sir, lacking again, okay, lacking one more electron. So where do we find that extra electron to fill this out? Okay, what we do is we add another aluminum, okay, having 3 valence electrons, 1, 2, and then 3, and then just let's say this electron here is transferred to oxygen, all right, such that it completes the shell, the valence shell of that oxygen. And then again, there are 2 extra electrons. So what we can do is add one more oxygen atom with 6 valence electrons. 1, 2, 3, 4, 5, 6. And then there it is. We have somewhere to place these 2 extra electrons. So there, 1 and then 2. All right? So now everything from the metal is completely transferred. Okay, let's assume the aluminum here is a metal, and then oxygen's atoms are also filled. So we end up with 3 aluminum ions, 3 Al. The charge, by the way, is plus 3. Alright, so why is it plus 3? That's because it lost its 3 electrons. It got rid of its 3 electrons. Okay, behaving as a metal, aluminum got rid of its 3 electrons. And then we in doing this, we usually write the metal first, then the non-metal. So metal, non-metal. Alright, and then we also have 3 ions of oxygen. 3, and then bracket, and then O. So 1, 2, 3, 4, 5, 6. Each oxygen atom has received 2 new electrons. So 1, 2. So therefore, we place there the charge 2 minus, and then enclose it in a bracket that way. All right. So that gives us, by the way, there are only 2, sorry, there are only 2 aluminum atoms. So scrap that. So this is only 2. All right. And then how did I find out that it has, this should be only 2 here instead of 3? Then one way to figure out or to check is through the net charge. So 2 times 3, this is plus 6 here, aluminum, and then 3 times negative 2, negative 6. All right, so that is plus 6 minus 6, that's equal to 0. Okay, so the net charge for ionic compounds is 0. And if you try to write the formula, that's Al. And since there are 2 atoms of aluminum, sub 2, and then O3. All right, Al2O3. Or simply, you can just have the charges. Al plus 2 plus O, or rather plus 3 here, O minus 2, so you end up with crisscross, disregard the charge, that's Al 2 O 3. Alright, so that's it. Ionic bond formation through LEDs. Okay, I hope you've learned something new today, and these are now the compounds or some active ingredients for some certain chemicals, calcium sulfide, aluminum oxide, and so on. All right, so I leave it up to you to do the exercises later on, and then enjoy the rest of the day.